Alright, so this is section 1.3 or unit 1.3, and what I want to cover here is do a quick review of imaginary numbers and what they stand for. So we've got a couple of examples here to take a look at. Our generic rules for imaginary numbers stand as follows: that basically if you have I squared, you can replace it with -1, but really how we use this rule is if we have a -1, then we can let it become I squared, and then you have the rule down below. So what this really translates into for us is that when we have a negative under a radical, what we want to look at this problem as being is it's -1 times +4. So utilizing our rule here that says that if I have a -1, I can replace it with an I squared, what comes out of the situation is now I'm actually can translate this into I squared times 4. And then mathematically, if we follow the properties, then we could actually think of this as being the square root of I squared times the square root of 4, which you don't have to do. You can go ahead and take the square root of these at this point. But when we pull this out, the square root of 4 is 2, and the square root of any number squared is just the number. Simplify that and put it in the correct order, and we get the answer of 2i. So we take a look at the next one. Just to immediately see the solution here, we know that because we have a negative inside, that negative translates out to an I. We know that the square root of 81 is 9, so 9i is our solution. Now let's see how we got that. So we come across this situation, we say, okay, well this becomes -1 times 81. We know that that -1 turns into an I squared times 81. We then at that point know that the square root of I squared is I, and the square root of 81 is 9. And so there's where our 9i comes from. In the next problem, we have to actually go a little bit further because 48 is not a perfect square. So we dig deeper into this problem, and we still replace things. We still think about it. So this becomes -1 times, well, I know that 16 times 3 is 48. So 16 and 3 give me 48. 16 is a perfect square. It's the best option that I have, because if I did my factors of 48, I'd have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 doesn't go, 6 and 8. And out of that list of my possible factors, the only perfect square is going to be 16. So that's a whole nother, that's simplifying radicals. It's a whole nother conversation. So at this point, we simplify this out one more time. The -1 turns into I squared. The 16 stays, the 3 stays. Now we start breaking it down. We start pulling things out. The square root of I squared is I. The square root of 16 is 4. And you can't take the square root of 3, so it just stays inside. So this answer becomes 4i square roots of 3. Okay, at this point, if you want to hit pause and take a look at number 4 and try it yourself, please do. Otherwise, just keep on watching, and then you'll get a chance to practice when you're working inside your assignment. So in this case right here, what happens is that I break it down again, and I start thinking about, okay, well, how can I break this down? So I've got -1 times, well, I've got to think about the factors of 72. So let me show you a quick trick here. So a cool thing I can do with my calculator is that I can take a look at 72. So, I'm trying to figure out what are my factors of 72. Get that calculator back up here. Alright, and so I want to find my factors of 72. So I can actually go to y equals. I can type in 72 and divide it by x. I can then go to my table. And so what I have here in front of me is these are my factors of 72, because my equation is 72 divided by x. So I go to my table, second, table, and now I can see that 72 divided by 1 is 72. 72 divided by 2 is 36. 72 divided by 3 is 24, so forth and so on. Well, the one that matters to me, the one that I care about, is 2 and 36, because 36 is a perfect square. So now I've got 36 times 2. And now I'm ready to roll. Oops, yeah, now I'm ready to roll. I'm ready to go ahead and replace that negative 1. Let's see, so this becomes a square root of I squared times 36 times 2. I start taking the square roots to pull things out. The square root of I squared is I. The square root of 36 is 6. And the square root of 2 I can't do, so I just put the square root of 2. Final solution would be 6i square roots of 2. So this is a quick little video to run through how to handle I inside of your radical and non-real solutions that you're going to run across in section 1.3.